Okay, so this is a little bit of extra practice with factoring. I'm actually at the smartboard now, so hopefully my writing will be better than the last video. Okay, so if you already watched the other video, you should know that we'll be focusing on the quadratic piece and the constant piece of each quadratic first. That's where we get our possibilities of numbers that are going to go in our parentheses. Our possibilities are going to come from the quadratic piece and the constant piece. We pick our choices based on the middle piece, the linear piece, after we have all our choices made. Okay, so from the quadratic piece, it's a 12x squared. So we know that our possibilities for that are 1x and 12x. And I think on the video I was always writing that 1x is just an x. It doesn't really matter. We could have 2x and 6x. And we could have 3x and 4x. That would cause a 12x. And remember, those are going to go here and here. And we just need to decide which of them we want and where do we want them. As for our constant piece, it's a 3. Luckily, that only has our choices of 1 and 3. And again, those are going to go here and here. We just need to decide which goes where. So one thing that we needed to look at was that the sign of this 3 is a negative. So we know that this is going to be a difference table. We are looking for, when we do all of our combining, we're looking for things that will have a difference of the middle number, so a difference of 5. All right, so let's try some linking up here and see what's going to get us a difference of 5. So one choice could be to link the 1 with the 1 and the 3 with the 12. So that would give us a 1x and a 12x. But those have a difference of 11, which is not what we want. So say we still stick with the 1 and the 12, but instead of linking the 1 with the 1, let's say we link the 1 with the 12 and the 3 with the 1. So we would have a 12x out of this guy, and we would have a 3x out of those. But those have a difference of 9x, so that's not helpful either, because remember we want a 5. So we know it's not that one, no matter how we do it. Okay, so let's try the 1 and the 3 with the 2x and 6x. We could go 1 with 2x, that would be a 2x. 3 with 6x would be an 18x. But those have a difference of 16x, so we don't want that. Let's say we switch that. The 1 with the 6, so that's a 6x. And then the 3 with the 2, that's also a 6x. Those actually have a difference of 0, so that's not what we want. So this one's no good. All right, so let's try it with this last one. We could go the 1 with the 3x, that would be a 3x. And then the 3 with the 4, that would be a 7x. Those have a difference of 4, which was close, but that's not what we want. So let's switch. The 1 with the 4x, that's a 4x, and the 3 with the 3x, that's a 9x. There we go. Those have a difference of 5. And I know that seemed like it took forever. The more you do this, the faster it's going to get. You won't need to go through all the choices. You'll be able to better see what the answer is right away. Okay, so we know that we want the 3 and the 4x. So 3x and 4x. And now we just need to be careful where we place our 1 and our 3. So we knew that we wanted the 1 to link up with the 4x. So that means I've got to put the 1 in the other parentheses as the 4x so that I actually get to multiply them. And then I know that I want the 3 to link up with the 3x, so those have to go in opposite parentheses. So I'm going to put this 3 here. And then we need to talk about signs. So really, that linear term in the quadratic up there was a negative 5x. So in order for that to happen, I need this 9 to be negative and the 4 to be positive. So I could get a negative 5x when I combine them. Which means, so let's see, we want the 4 to be positive. So that was coming from here, the 1 times the 4. And then we want the 9x to be negative, and that was coming from the 3's. So When I multiply this, I should get my 9x, negative 9x, and my positive 4x, which will combine to be the middle. And again, to double check, you could always distribute out the whole thing. You could take the 3x times the 4x, then the 3x times the negative 3, then the 1 times the 4, and the 1 times the 3. And you should get that top quadratic if we did it right, which we did. Okay, second one. Second one is a weird quadratic. It has a quadratic piece and a constant piece, but it's missing the linear piece. So I'm going to write that in. I'm going to rewrite this as x squared plus no x's minus 9. And then we're going to treat it the same way. So our quadratic piece is x squared. The only thing that causes that is x times x. Our constant piece is 9. The only thing that causes that, oh, we got two choices, 1 and 9, and 3 and 3. And since it's a negative 9, we know that this is going to be a difference table. So we're looking for things that have a difference of 0 when we link them together. So if we go ahead and try that, we could link the x with the 1, that'd be a 1x, and then the other x with the 9, that'd be a 9x, but those have a difference of 8, so that's not what we want. If instead we link the x with the 3 and the other x with the other 3, 3x and 3x definitely have a difference of 0. So then we can write this as x and x, we know that's what we want, and we want the 3 and the 3, and we don't have to think as hard when it's an x and an x. When the beginning part is identical, it doesn't really matter where you put the other guys. They can go in either one. And okay, let's see. To be a difference of 0, one of these guys has to be negative, and one of these guys has to be positive. So we'll do that up here as well. And if we multiply that out, we should get x squared. We'll get x times x would be x squared. X times negative 3 would be negative 3x. Then we would have a positive 3x to cancel, and then positive 3 times negative 3 would be negative 9. So that would get us our x squared minus 9. Okay, let's try a few more. All right, so in this third example, again, we're focusing here on the quadratic piece to get our choices. 3x squared is formed by a 1x and a 3x. That's all our only possibilities. We'll also be focusing on the constant. Possibilities for 14 are 1 and 14 and 2 and 7. And since it's a negative 14, we know we're looking for differences. And we're looking for a difference of 1. That's a 1 in front of there, right? Okay, so let's start linking and see if we can get a difference of 1. So let's say we link the 1x and the 1, that's a 1x. The 1x and the 14, that's a 14x. But those have a difference of 13, so that's not what we want. What if we did the 1 and the 14 and the 3 and the 1? So then we would have a 14x and a 3x, but those have a difference of 11. That's not what we want. So no matter how we do this, it won't work. So let's go here. The 1 with the 2 is a 2x. The 7 with the 3 is a 21x. But those have a difference of 19. That's not what we want. Oops, we can leave that. So what if we try this? The 3x with the 2 and the 1 with the 7. There we go. 7x and 6x have a difference of 1. So this is the link we know we want. So here's our parentheses. And let's see, we've got our x and our 3x that must go there. Now we need to be careful where we place them since x and 3x are different. It matters where we put the 2 and the 7. So the 1 is supposed to be linked with the 7. So that means the 1 and the 7 need to be in opposite parentheses. And the 3 and the 2 are supposed to be linked, so the 2 needs to be in an opposite parentheses as 3. And then let's do signs. All right, we want a difference of positive 1. So our 7 has to be positive and our 6 negative for that to happen. Okay, so 7 has to be positive, so that's this guy, this link. So x times, that needs to be a positive 7 for this to work. And then the 6 needs to be negative, that's this link. So then the 2 has to be negative for that to work. And then again, we could always multiply this out to double check. But it looks good. All right, just a few more examples, just to make you feel a little bit more comfortable. All right, so focusing on our quadratic piece, x squared, our only choices are x and x. Focusing on our constant piece, 6, we've got 1 and 6, 2 and 3. It is -6, so this is a difference table. We've done only difference, sorry about that. So we're looking for a difference of 5 when we link together. So let's try that. X with 1, that's 1x. And x with 6, that's 6x. There we go. 1x and 6x have a difference of 5. Cool, I love it when we get it on the first one. All right, x and x. Since these are the same, doesn't matter where I put the 1 and the 6. I don't have to think too hard. I do need to think about signs though. We want a positive 5x. So that means the 6 needs to be positive and the 1 negative for that to work. So 6 positive and 1 negative. There we go. You could always multiply out to double check. Okay, we've got another weird one next. We're missing that linear piece again. So 25x squared, we need to put in the 0x, then the -4. All right, so for our quadratic possibilities, we've got 1x and 25x, and then separately 5x and 5x. And for our constant possibilities, 4, we've got 1 and 4 and 2 and 2. And then since that 4, that constant is negative, this will also be a difference table. Sorry again, this is all we seem to be doing. And we are looking for a difference of 0 when we link up. And the only way that will happen is if we link up and we get the same result. So hopefully by now you're kind of seeing like, where do we really need to start at the beginning? Hopefully you can see that if I want to get a difference of 0, I need to get the exact same link. So this is where we really want to go to get a 10x and a 10x. So they're the exact same thing, they have a difference of 0. And like I said, the more you do this, the faster you'll be able to see what the answer is so that you don't have to go through all of the possibilities. Okay, so let's write this out, being careful about where we put things and our signs. So we've got 5x and 5x. Since those are the exact same start, it doesn't really matter where I put the 2 and the 2, plus they're the same anyway. Okay, let's do signs. In order for us to get a 0, we need one of these 10s to be positive and one of them to be negative. So we'll do that up here as well. There we go. You can always multiply it out to double check that it ends up being 25x squared minus 4. Okay, last problem. So our quadratic piece is 4x squared. That comes from 1x and 4x, 2x and 2x. And our constant piece is 15. That comes from 1 and 15, or 3 and 5. All right, hey, this is a sum table. That 15 is positive. Okay, so now we're looking for a sum of 16. So instead of a difference, when we link, we want them to sum, so add to be 16. Okay, so again, the more you do this, the faster it'll get, but I'm just going to kind of go in order for now until we get there. Okay, so the 1x and the 1, that would give us a 1x. The 4 and the 15 would give us a 60x. Those definitely do not have a sum of 16. They have a sum of 60. That's too much. So what if we switch that? The 1 with the 15, that's a 15x, and the 4 with the 1, that's a 4x. Nope, those have a sum of 19x. That's not what we want. So we can't do the top two together. So trying to kind of be organized. Let's stick with trying this, but now we'll try it with this second set of ordered pairs. Okay, so let's see. If we do the 1 with the 3, that'll be a 3x. The 4 with the 5 would be a 20x. That's a sum of 23. That's too big. Let's switch that then. The 1 with the 5 is a 5x, and the 4 with the 3 is a 12x. That's a sum of 17. Still too big. So then we know we've tried the 1 and the 4x with both things. It's not working. So it's got to be 2x and 2x. So let's try it out. So again, I'm just going to kind of go in order. 2 times the 1 would be a 2x. The 2 times the 15 would be a 30x. That's way too big. As a sum, we only want 16, not 32. Let's see, so it can't be with that because even if I switch, I'm still doing 2's. It better be this, it better be this. Okay, 2x times 5 would be 10x. 2x times 3 is 6x. There we go, there's our sum of 16. All right, and let's go ahead and try and write this then. 2x and 2x. Since these are both the same, I don't really have to think as hard about where my 3 and 5 go. You can put them in either spot. But we do have to be careful with our signs. We want a positive 16, so that means that both of these have to be positive. There we go. So both of those have to be positive. All right, hopefully that's helpful. We're gonna do some more practice with this in class. If you did not watch the first video, please go back and watch the first video. It's really helpful too.